This would be our second problem on the measurement of stream flow. The first was one moving board method, and this method is on area velocity method. So we take sections, and for the section, we take uh, velocity measurement at different location, mainly point 2 d, point 6 d, point 8 d depth, and we have maybe uniform area sorry uniform section, or maybe of a different width. In this case, you will see that the width may not be uniform. So if I draw the cross section, you will visualize it more clearly. See, you have how many sections are there? One, two, three, four, five, six, seven, eight. So let's say this is our first one. So this would be our, like, this one would be maybe the point 0.8 distance. So this the section size is, sorry, the width is point 0.8, and the next one would be point 0.8 as well, because the distance from 1.6, sorry, from point 2 to 1.6 is point 0.8, and the distance from 1.6 to 2.4 is point 0.8 as well, and the distance from 2.4 to 3 is point 0.6, and the distance from 3 to 3.6 is point 0.6, and the distance from 3 to 6 to 4.2 is point 0.6, and the distance from uh, 4.25 is point 0.8, and the distance from 5 to 5.8 is point 0.8. So this was the beginning from one bank, and it was the end of another bank. So this is the cross section. Maybe if you draw the cross section, the river might be like this, maybe like this. You measure the depth here, and you take the velocities here, here, like this. So let's concentrate on the first point where we measured the depth. The depth was zero point 0.5, and it was less than zero point 0.6. So for that, we sorry, point 60 at point 60 of zero point 0.5, we take a velocity of 0.125, and the average would be the same, 0.125, and the width would be, for this point, half of this segment, like here, and half of this segment, and half of this segment would produce zero point 0.4, and half of this segment would produce zero point 0.4, so it would be zero point 0.8, sorry, zero point 0.8. And for this section, second one, you would take an average of the two velocities of point 2 depth and point 0.8 depth. So you will get an average velocity of point 2 to 3, point 2 to 3. And for the second one, this is somewhere over here. You have half of point 0.8, and you have half of point 0.8, so it would produce point 0.8 as well. And for this one, it would produce an average velocity of 0.27, 0.227, and you get half of point 0.8, which is zero point 0.4, and half of point 0.6, which is zero point 0.3. You will get a width of 0.7. And for these 1.268 and 0.221, you will get an average velocity of 0.245, and you will get a width of zero point 0.6, half of zero point 0.6 and half of zero point 0.6. And for this one, 3.6, you'll get an average velocity of 0.243. You'll get an width of zero point 0.6. And for 4.2 depth, sorry, 4.2 distance from bank, you'll get an average velocity of 0.237, summing these velocities and dividing it by 2. And here the distance is zero point 0.7 because it is zero point 0.3 and it is zero point 0.4, so zero point 0.7. And here you will get an average velocity of 0.227 and the distance is zero point 0.8. Eventually, you will find the discharge. Find the discharge for the section. That would be the multiplication of this velocity and the area. To get the area, you will multiply your W value with your depth, like this. So you want to you have average velocity of this section, and you need to the area. So for that area, you have this width, this width, and you have the depth here. So you multiply the width with the depth to get the area, and then you multiply the velocity to get the discharge. So for the first one, the discharge was 0.05, multiplying zero point 0.8, 0.125, and zero point 0.5. And the second one, it was 0.18, it was 0.25, it was 0.294, it was 0.2916, and it is for 0.299, it is 0.22. For 0.22, you multiply zero point 0.2 with the average velocity 0.227 and the depth, which is 1.8. So now you want to know the discharge. So Q would be the summation of del Q, and the summation of del Q will produce discharge of 1.5 meter cube per second. And there is no correction factor, and you don't need that as well. So this is how you find out the discharge for a section of a stream using area velocity method.